All right, guys, Unit 8, Lesson 3. Students will be able to solve area problems with right triangles. Day before yesterday, we did rectangles. Yesterday, we did parallelograms. And today, we'll be doing triangles. Okay. It says measure the area of the square and triangle below. So for the square, I can still use the same formula for the rectangle to find the area. So A is equal to its length times its width. So the length is 3, the width is also 3. So let's go ahead and substitute those in. 3 by 3 gives me 9. So we know the area of this figure, 9. 9 square units. Now, let's look at the second figure. It looks similar, but it's just one little thing about it. It looks exactly like the square, except it looks like it's split into a half of that square. So I'm going to say that this height is still 3. I'm going to say that it's still 3 right here, but it's also not the entire thing that's being covered. It's half of it being covered. So we can go ahead and assume that it will be half of the area of the square to the left. So I'm going to go ahead and say that half of, and I'm not going to use length and width. I'm going to use base and height. I'm going to say that the area of this figure, this triangle, will be half of the area of this square, which is why I put the 1/2 here. So let me go ahead and use substitution to figure out what that is. The base is 3. The height is 3. So 3 times 3 is 9, but 9 times 1/2 gives me 4.5 or 4.5. So that'll be 4.5 square units. Some of you might put 4.5, either one works. So it looks like the formula is simply half of whatever the square or rectangle is. So in the explanation area, it says explain how you measured the area of the triangle. So I noticed that the second diagram is split in half. That means it takes up half of the space, which is why I divided the first diagram by 2 to figure out what the second diagram is, okay? That's how we got 4.5 square units, all right? So knowing that information, let's go ahead and go straight to the conjecture. Your explanation can go here, just make sure it's nice and strong. So from my example that I just did on the previous page, I'm going to say that the conjecture will be the area of a right triangle is half the area of a rectangle with the same base and height. Oops, spelled base wrong. Base and height. Let's go ahead and test this out to see how it works. So it says, Selena has a rectangular plot of land that is 3 yards by 2 yards. So I believe this is the 2. Its height is 2. And its base is 3. Okay, I'm gonna underline that. She wants to create a garden in the shape of a right triangle. Selena drew a sketch of the plot of the land and the triangular garden she wants to make below. How big in square yards will her garden be? So it looks like we only want the triangle. So if we took the area of the entire lot, it would be its length times its width, which is simply 2 times 3, which would be 6. But that's not what we're looking for, guys. That's the rectangular plot. We want the triangle itself. And we notice that from our conjecture, the triangle is actually half the area of the rectangle. So let's go ahead and write our formula down. A is equal to 1/2 the base and the height, okay? So what are we given? Are we given an area? No. Are we given a base? Yes, we are. The base is 3. And what about the height? The height is 2. This is my little key right here. I'm going to put it to the side. Now I can do my substitution. A is equal to 1/2. Our base is 3. Our height is 2. And now I can just do some quick computation. 1/2 times, you can do this one in your head, times 6. And 1/2 times 6 should give you 3. So the area will be 3 yards square or 3 square yards. Okay, so did our conjecture prove to be true? Yeah, because 3 is half of 6. So therefore, the triangle's area was half of the rectangle's area. Our conjecture proved to be true. Let's just make sure we annotated this well enough to know that we answered the question. How big in square yards? We figured out how big, and yep, up to the next one. What is the area of the triangle below? So they gave us 3 numbers, guys. And if we're talking about a triangle, there is a specific formula, and we just used that formula on the previous page. That formula is 1/2 times its base times its height. What are we given? Because there are 3 numbers here, I don't know if all of them will be useful to us. So is the area given? No. Is our base given? Which one is a base? Typically, it's the number at the bottom. So 15 is our base. What about our height? Our height would be from the base to the top of the figure. So our height is 8. Now, a lot of you may be asking, well, why did they put the 17 there? Well, they put the 17 there for a few reasons. They want to see if you know exactly what numbers you are supposed to use. 17 is not needed to answer this question. It's not needed, it's not necessary. We don't need that to answer this because all we need is our base and the height. Now we can do our substitution. A is equal to 1/2 times 15 times 8. Now, where can you do your side work? You have enough space right here to figure out what 15 times 8 is. I'm going to say that 15 times 8 is 120, but 120 is not the answer because we still have to multiply by 1/2, which is taking half of 120, which will give me 60 feet squared. As you can see, my processes for the first 2 or the first and the second questions are the same. I wrote down my dimensions. I figured out what my base and my height was. I know for a fact that I'm using this formula because they're saying what's the area of the triangle below. Okay, so once I figure that out, I figure out what's given, and then I do my substitution. I simplify it, and I am left with my answer, 60 feet squared. Okay, the conjecture proved to be true. Well, yeah, because if I make this a rectangle, notice I'm doing dotted lines because it's not technically there. This would simply be 8 by 15 if I took the area of this rectangle. And 8 times 15 is 120. And that will be the area of the rectangle, and the area of the triangle should be half of that. Half of 120 is 60. So therefore, we are correct. We proved our conjecture to be true, guys.